In this short video, we're going to learn how to calculate the amount of energy that's either released or absorbed during an experiment. We're going to look at each of the different terms in the equation. What are they, what do they mean, and what are their units? So the equation we're going to look at in this video for how to calculate amount of energy released or absorbed is Q equals mc delta T. And here Q is the energy that's released or absorbed in a reaction. And you might remember from school about endothermic and exothermic reactions. Q comes out in joules, which are a unit of energy. M is the mass of solution. Now, even if you're given a mass of a solid, we do not use the mass of the solid in this equation. It's always the mass of solution, which could be water or it could be a dilute solution of hydrochloric acid or something like that. And then C is something called the specific heat capacity. And this is the amount of energy in joules required to raise 1 gram of a substance by 1 Kelvin. And lastly, delta T. That triangle is a Greek symbol called delta and it means change in. And capital T is temperature. I've written Kelvin for the units of delta T, but we'll soon see shortly that it doesn't matter whether the units of delta T are in degrees Celsius or Kelvin. Next, you might want to pause the video here to jot down these useful conversions. Now, these conversions you'll need to be able to answer questions using this equation. At the top, we've got how to convert between kilojoules and joules, which are units of energy. A kilo means 1,000. It's just like grams and kilograms. We've got units of temperature, degrees Celsius and Kelvin. If you're unfamiliar with Kelvin, it's just a different temperature scale. And we add 273 onto the temperature in degrees to get it into Kelvin. And lastly, the most important conversion in this part is the conversion between units of volume of solution, which are given in centimeters cubed or mils, into grams. So 1 mil is equal to 1 centimeter cubed, which is equal to 1 gram for dilute solutions. Earlier I mentioned that it doesn't matter about the units of delta T, the temperature change. How can that be? We're going to prove it now. So imagine we had a reaction that started at 50 degrees and rose up to 150 degrees. What we do is we subtract the smaller number from the bigger one. So 150 minus 50 degrees, which gives a difference, a delta T of 100. Now we're going to convert these values to Kelvin by adding 273 to the higher temperature and to the lower temperature. Then we'll do the same as we did before, bigger number minus smaller number. So 423 take away 323 gives a difference of 100 again. So delta T is 100 no matter which unit of temperature we use. And that's the end of this part 1 introductory video on the equation for calculating energy absorbed or released through a reaction. Please like and subscribe if you found this helpful, and join me for part 2 on how to apply the equation and how we can use Q to calculate delta H.